In the previous video, I showed you how to solve a pretty basic separable differential equation. In these classes, I really encourage students to use LaTeX to type up their solution. And what you're looking at right now is the raw LaTeX code on Share LaTeX, which is a website that allows you to collaboratively work on these kind of documents. There are a couple of style suggestions that I want to go over before we talk about the LaTeX-y stuff. Generally speaking, when you're showing your steps in computations, line up your equal signs vertically, one per line. Okay, and you can do this using the align command, and I'll point that out in a moment. Indent your code to make it more readable and ultimately editable later. So when you're going back and looking at this stuff, it makes it a bit easier to work with. Show only the relevant, in other words, calculus and differential equations steps. You don't really have to show the arithmetic. You can if you want to, but really you don't need to. I know in the previous video I was very explicit with the solutions, and that was because it was kind of an instructional video. When you're actually typing up your solutions, they should be a little bit more tighter than that. So show only the relevant calc or diffie-q or whatever class you're working on steps. And then you want to interpret your solutions and your steps in the context of the problem that you're working on and the class that you're working in. So in other words, you want to talk about why the bounds are where they are, or what this particular graph actually means in terms of the particular problem. Say if there are units involved like time and money, you want to interpret which axis is with which and so on. And then lastly, and more generally, you want to communicate your thought process so the reader does not have to assume or guess at what you did. So at every step, a reader who is, in the same place as you in the class should be able to read your document and say, oh yeah, I see what you did there, I see what you did there, and I see what you did there, and I understand, the steps. If your reader or teacher even is looking at your work and saying, well, did you solve using quadratic equation? Did you solve using a calculator? Is this supposed to represent time? Is this supposed to represent, money? What are these two? If I'm asking questions, if your reader's asking questions like these, you probably need to include a little bit more exposition. And it doesn't have to be a novel. It can just be a short sentence or two, or more modern terminology, even a tweet will suffice. So with that said, here's the code for the problem that we previously solved. And I'll show you what the output looks like just by clicking left, this PDF button over here. It'll compile. I'll make it a little bit larger so we can read it better. There we've got our title, name, date, and there's the problem. Given this differential equation and initial value, solve the IVP exactly, y is a function of x. And then we go through and we do what we did before, but it was a little bit more, like I said, a little bit more tight, more clean. So dy dx is that. Separate and integrate. Oh dear, I forgot the integral symbol. I have to go and include that. Take our constants and get the final result. And then I show how to combine the constants into C, use initial conditions to solve for C. There we go ahead and do that in one single step and find C as -3. Here's the lovely thing about Share LaTeX. This is all run from my web browser. I said I forgot the integral symbol, so let's go and add that in. And this shows why indenting the code makes it more readable and editable. So it's number 1A, and I forgot the integral symbol. So all I'll do is I will go over here to this step and write int, and when I click PDF again, it should appear. And lo and behold, there it is. Okay. So you can see I showed a couple of steps, the relevant steps, solved for C, and then I said now we want to find and express y as a function of x. We want to find, I should put a comma there, express y as a function of x. We can do this by noting that we ultimately have a quadratic equation in y, use a quadratic formula to solve for y. And then I do that in like 2 steps, right? Some people can do this all in their head. If you can, that's great. But when you're typing it up, you don't actually have to go through every single arithmetic step if you don't want to. You can just set it up and give the final, answer at the end there, because that's really just like Algebra 1 type stuff. At this point, we got to use some differential equations. We have to apply the initial conditions, determine if we should use the positive, negative, or perhaps both part of the square root. So we go ahead and do that, and we get that 1 equals 5 halves plus minus 3 over 2. Therefore, y is equal to 5 halves minus, right? It's the minus part we want. Because, and here's that one line of exposition, because 5 halves minus 3 halves equals 1, and 5 halves plus 3 halves is 4, which is not 1. Okay? Showing this part was very easy. We went and created it. We just input the image. I'll show you how to do that. And then the interval of validity, like I said, very short. Function is defined only when the following is true, because that's under the square root. Using a computer, we find that x is in this interval, and we're done. If there were more questions, they would be down there, and we'd go ahead and answer them in the same fashion. So let's have a look at how exactly, stylistically we did this. All the equal signs are lined up. Equal sign, therefore sign, equal sign. And then look over here. Equal signs are all lined up. How did I do this? We go to main.tex, the main tech file, and you'll see that we have this line here, begin align, end align. And the star means that there are no equation numbers. If I remove that star, I will get equation numbers. The ampersand means line up here. The double backslash means break line here, and there's no line break on the last one. That's the general rule, and you'll see we did that here, and there, and there, and that's really all we used it. But like I said, if there's a star, there are no equation numbers. If there isn't a star, then there are equation numbers. So if I recompile, you'll see that the first 4 equations are automatically numbered. If I don't want them to be numbered, I'll just go in and add that star, just like with all the other ones, and that will remove the numbering. I'll click PDF and remove the numbering. And now they're gone. Okay. And you may wonder, how did I include this image? First of all, I had to upload the image to my Share LaTeX folder, and I did that just by clicking down here where it says Upload File. I'll click Upload File. It'll say select a file or drag it. I've already done that with this, which I've saved as a .png image. I go into my main.tex file, and right here, begin center, end center, and then include graphics. Scale equals 0.5, and then figure.png. You shouldn't have any spaces, and try and avoid spaces, because that tends to mess with things. It is possible to generate things within LaTeX using TIKZ, PGF, and all sorts of PostScript tricks. I'm not that good. This is a quick and easy way to do it, so if you're doing this, you're totally fine. If you can actually generate your own, more power to you. That's awesome. And that's really the rest of the document. I've got a couple of packages, which I'll show you how they work. Full page gives me full page margins. So again, have a look at the margins on my page right now. You can see they're quite wide. And if I go to main.tex and I get rid of, that comment line, I'll now be using the full page package. I'll click PDF. Notice how my margins are a bit wider. Okay. You can fit more on your page. If I want to undo it, it's pretty simple. I just comment it out. Now, Euler VM and Bookman, those are two different fonts for math and symbols. So if I click PDF, this is without using Euler and Bookman. This is the default Computer Modern font. Okay, have a look at what this font looks like. It's kind of thin, it's kind of sharp, very professional looking. You probably see this in a lot of undergraduate style PDF notes that you'll see out there in college. If I use Bookman and Euler VM, and I go to PDF, okay, the font is a little bit thicker. The math font changes a little bit. I find this a little bit easier to read sometimes because just my personal preference, and whatever you like is your preference. It really doesn't make a difference, but it's nice to know that it's there. And everything is clearly labeled. I've got my packages labeled, I've got my title bit labeled, and then I've indented everything so that I can easily find what's what. And then for each problem, I tell what problem and what part it is in case I need to go and edit stuff later, or send it to my instructor maybe, and have my instructor look at it and then change the code around. All right, I hope you found this useful, and if you have any questions, please let me know. Have fun.